two parallel vertical smooth wall. That means EF, this one, and CD, this one, meet a horizontal plane at E and C respectively. A uniform smooth rod AB of weight 2W and length 3A is freely hinged to the horizontal plane at the point A between E and C. Okay, and the end B rests against CD, okay, which is here. A uniform smooth circular disc of weight W. This one, circular disc, is in contact with the wall EF at the point P, which is here, and with the rod at the point Q, which is here. It is given that the angle BAC is 60 degree. 60 degree, yeah. And that AQ equal to A. AQ here to here A. So that means the other side is 2A, yeah? Altogether 3A. The rod and the disc are in equilibrium. Okay, so in the same vertical plane, which is perpendicular to both walls. Show that the magnitude of the reaction at P is square root 3W. Okay, so reaction at P, which is here. First of all, we need to know, because the Newton's third law, right? So whenever the disc is touching the vertical wall, that is action. So then we have reaction in this way. Action. So let's say I call this RP. Okay, so I call this RP. Yeah. Reaction at point P. So we have to show that this RP is square root of 3W. What is very important here is this point, equilibrium. The rod and the disc are in equilibrium. Rod and disc. Okay, so that means we should expect the force to the left is equal to the force to the right. The force going up is equal to the force going down. And the moment, resultant moment is equal to 0. So we have to make use of that. Okay, so let's see first. This point, we need to build up some equation also. This point is where the disc is touching the rod, so should have action reaction as well. So let's say I call this RQ. RQ, reaction at point Q. RQ. Okay, so they all act towards the center of the circle. That's the thing, as they are radius at the same time. Okay, 90 degree and 90 degree with the tangent, and hence go to the center of the circle. Okay, so let's see first. We also have this 2W act in the middle, 2W act downwards, where here to here is 1.5A. So let me see first what other information we have. Weight W, uniform circular disc of weight W. So that means this is having the weight of W acting in the middle. 60 degree equilibrium. Okay, let's see how to make use of this 60 degree first. 60 degree. I need to add some lines here. So I use this, like this. I create a horizontal line here. So that is going to be 60 degree at this side. Then after that, let me see first. Let's say I call the radius of the circular disc as R. So hence this is going to be R, the radius, 60 degree. Okay, 60 degree is here. This is going to be 30 degree. As you know, the tangent and the radius are 90 degree. So since here takes 60, this small angle should take 30. So here is 90 degree. And hence this is 60 degree. Okay, so now I have enough information to apply, let's say, moment. Okay, I use moment. Okay, so since it is in equilibrium, so I can use clockwise moment equal to anti-clockwise moment. Okay, so I make use of this. Okay, let's see first the forces that I have over here. I consider only the force that act on the disc. The force that act on the disc. So I have actually this one, RP, which act on the disc. I also have W, which act on the disc. I also have RQ that act on the disc. I have three. Okay, so I have three forces that act on the disc. So imagine I draw it again. This is the disc. Okay, so this is RP that act on the disc. Point P is here. And I have W that act on the disc. I have RQ that act on the disc. So these three forces act on the disc. Okay, so let's say I draw a tangent here. This one, let's say this, I call it over. Okay. Now, we set a point as the pivot. Let's say I use cannot use center of the circle. If not, no distance for RP and no distance for RQ. So I can't find the direction at P. Then I cannot use this. As you know, this will pass through center. This will pass through center also. So no distance. I cannot use O as the center of the rotation. So let's say I use Q. Clockwise moment equal to anti-clockwise moment about Q. So if I use Q, right, the thing is I'm going to have distance. Okay, imagine this line, RP, I make it longer, RP, then I have distance. I have the distance here. This is the distance, D1. Okay. Then let's say W. W, I make it longer. Okay, then this is the distance. I call it, say I use different color, D2. I call this D2. D2, okay. So I find on D1 first. Just now you can see I have a triangle already, and this triangle is kind of helpful. This triangle. Okay. Now we know the radius, I already named it R, and I also know this is 60 degree. 60 degree. So because of that, this vertical part is put it here, R cos 60 degree. R cos 60 degree, yeah. So that is actually here to here, which is also D1. D1 is R cos 60. And then D2. D2 is opposite. So opposite is R sin 60. Okay. Now let's see whether we can form the equations for the moment about Q. Okay, let's take a look. So I have RP times D1. RP times D1. Okay, imagine this is the center. This is the center, right? So this direction is, imagine it's like that, clockwise. So this is clockwise, So this is clockwise. The W act this way. Imagine the center of clock here. So this way is anti-clockwise. So let's work it out. Clockwise equal to anti-clockwise. So we have RP multiply with D1. D1 is R cos 60 degree. Then I have W multiply with D2. D2 is R sin 60. Okay. Then I simplify this. RP, you know, cos 60 is 1 over 2. So 1 over 2 R. And sin 60 is 3 over 2. RW. Then I can cut the R on both sides of the equation. Then I can get RP in terms of W. RP, okay. RP equal to, okay, times 2. I'll cut the 2 off at the bottom. So it becomes 3 W. So we managed to show it for the first part. Okay, that's the first part. And now let's look at the second part. The magnitude of the reaction at B. At B. Reaction at B is 7 3 over 9. W. Reaction at B. Okay, so which means this one. B. Okay. To find B. B is 7 3 over 9 W. Okay. This is the reaction that act on the act on the uniform rod. Uniform rod. We have RB. We also have 2W. 2W. We also have Q. We also have this A. Okay. So since this is in equilibrium. Okay, I put it like this. This is RA. Okay, imagine for the rod alone. For the rod alone, this is the rod. So I have RB that act here. I have W that act in the middle. Sorry, 2W. I also have RQ that act this way. Then I also have RW that act this way. Sorry, RA, RA. This is point A. This is point B. Okay, so our main thing is we want to find RB. So since this is in equilibrium, we have plenty of choices. We can use equilibrium in vertical, equilibrium in horizontal, or we can use moment. Okay, so let's say, let me see first. I have 60 degree. I have 3A. 3A is the whole line. Okay, let me put in different color. This is 3A. And this is 1.5A. And here to here is 2A. Here to here is A. Okay, so in that case, let's see how to form so many information. Okay, so moment or forces in equilibrium. B. We cannot use moment about B for sure. And moment about okay, let's see first. Here 3A cos 3A opposite 3A sine 60 degree RB times this okay, so let us use moment about point A. About point A. Okay, so I don't choose moment about this point because I want W in my answer, so I don't choose this point. I want W in my answer. I either choose this point or this point. Okay, about point Q or about point A. So let's say I choose about point A. So moment about point A. So clockwise moment equal to anti-clockwise moment. This is about A. Okay, so I choose this particular point. I have, okay, let me set up first. I have RB as, this is the center of the clock. So imagine you turn this way. Okay, so that is going to be, this is going to be anti-clockwise. This one like that, anti-clockwise. This one clockwise. Okay, so I have two anti-clockwise that I should put on the right, and I have clockwise that I should put on the left. Okay, so let's form the clockwise, anti-clockwise, anti-clockwise. This is on the rod. Okay, this one I need to change direction. This one, the RQ. RQ I need to change direction. Basically, the reason is because if I put in this direction, right, it act on the disc. Now what I want is act on the rod. Act on the rod should be this way, right? You know Newton's third law, right? That is action reaction. So the action is acting on the rod. The reaction is acting on the disc. So I want the force that act on the rod. So that's why I don't want this direction. I want this direction. From the disc to the rod. So I change into opposite direction. If not, it doesn't work. Okay, so this is RQ. Okay, so if I change it to this direction, right? So this become, imagine, this become clockwise. Huh? So these are the forces that act on the uniform rod. Okay, so I have 2 clockwise. So let's form the equation. 2W. 2W, let's say I extend it to W. And because of that, I need the distance from here to here. Okay. So that is 2W going down. So the distance here to here is hand 1.5, 1.5A cos 1.5A cos 60 degree. So which is here 2W times that. Okay, let me write down first. 2W 1.5A cos 60 degree. So this is the clockwise moment. Then I have another clockwise moment, which is, this is anti-clockwise. This one I cancel first. This. Okay, now I have the RQ. RQ is another RQ perpendicular distance. The distance is A. Here to here is A. Okay, so RQ times A. Anti-clockwise moment, I have this one, multiply with the vertical distance here, which is 3A sine 60. So RB, 3A sine 60. Okay, then I simplified it. 2W. Cos 60 is 1 over 2. 3 over 2, 1 over 2, 3 over 4. 3 over 4. A. RQ A. B. This is square root 3 over 2. Square root 3 over 2 times 3. So I get 3 square root 3 over 2A. Okay, let's simplify this. Got the A. So we have 3 over 2W plus RQ equal to 3 over 2 RB. And what we need to show is 7 3 over 9 W. Okay, so that means we need to find out RQ. We need to find out RQ. So in order to find out RQ, to substitute here, and eventually you have to get this. So let's look at this. Let me see first. Either this or the rod. Q this way. If I consider that this will be this way, Q P to W. Okay, so I consider the this. As you can see here is the RQ acting this way. And the other thing is I know the W is acting down. And I know this is 60 degree. So I use alternate angle. I can transfer the 60 degree here. So what am I trying to do is I want to find out the component force here. This is going to be RQ cos 60 degree. RQ cos 60 degree. You see, I find the vertical component. So what I want is I want to form an equation to find RQ easily, and I found this is kind of easy. I consider the vertical component. Forces acting upwards is equal to forces acting downwards. This RP you can ignore because RP act this way. We can't resolve vertically. So forces acting upwards, RQ cos 60 degree is equal to forces acting downward, which is W. So at least this is something that head towards the answer that we are going to show. I try to find out RQ in terms of W, then I substitute here, then I can add, and maybe we can get the answer already. Okay, so RQ is 1/2 W, RQ equal to 2W. Okay, then once I get this, then I substitute here. So I have 3/2W plus 2W, 3/2 RB. Then I add this up, 7/2 W, 3/2 RB. So I want RB in terms of W, so I just move around, cut away the 2. Then I have 7/3 W. So what we need to show is this. Okay, I need to rationalize the denominator. I multiply with 3 up and down. 3 times 3 we get 3. 3 times 3 we get 9. 7/3 W. Okay, so we get to show it. So that is RB. We managed to show that. Okay, now let's continue. The next part. Find in the form KW the magnitude of the reactions on AB at A. That means find RA. Giving the value of K correct to 3 significant figures. So we want to find RA. Okay, so what we need to do, we need to either consider moment or forces in equilibrium, vertically or horizontally. We have to consider those things. Okay, now let's say I just consider the rod alone. Okay, let's see first. For the rod, we already consider moment, but the moment that we consider is about A, so that's why no RA is there. Okay, so we should consider RA. Okay, to consider RA, right, the easiest way is let's consider vertical first. RA is acting upwards. 2W is down. Okay, 2W. This one is here. Okay, so let's see. I draw again. So RA is up. The RQ is here. This RQ, right? So we need to know there is a downward component. Okay, let me resolve it. 60 degrees here. 60, 90, 30, 30. Okay, so I'm going to resolve this way. Form a triangle like this. Okay, let's say I make my RQ shorter a bit. Then it makes sense. Huh? So this is my RQ. Okay, this is my 60 degree. So this is the downward. The downward is adjacent to the 60 degree here. So this is RQ cos 60 degree, acting downwards. And this one is RQ sine 60 degree, x to the right. Okay, so acting downward is RQ cos 60. And we also have the 2W act downward also. And this one act to the left. There is no component that acts vertically for this. Okay, so what we need to take is this one, act upwards, and this one, act downwards. This one also act downwards. Okay, at least we can form an equation by doing this. Okay, so this is for vertical. For vertical, RA, these two are downwards, equal to 2W plus RQ cos 60. RA 2W RQ cos 60. I have RQ. Let me see first. RQ is 2W. If I substitute my RQ here, 2W cos 60, then I get 3W, 3.02. Seems like not so accurate. 3.02. I'm going to get 3W if I substitute this value inside RQ, which is 2W, right? 2W times half is 1W. 1W plus 2W is 3W. So 3W is not the answer. As they said, 3 significant figures and they give 5 marks. I cannot resolve in this one step, right? Okay, let me see first. What's the problem here? leave it like this first. 2W. The RQ, let's say I just put what I found just now. 2W. Substitute inside. Cos 60 is 1/2. So I get 3W. I'll leave it like this first. This is RA. W. Okay, the vertical. Magnitude of directions on AB. Magnitude of direction on AB at A. So I have RA on AB. So this is AB. Okay, this is a little bit different from part 1 and part 2. Let's take a look. You see in part 1, right? They say reaction at P. Reaction at P, this one. Reaction at B, this one. Okay, so what I found here is reaction at A. You know, when I say reaction at P is the perpendicular reaction. Reaction at B is the perpendicular reaction also. So this is reaction at A. Let me write down first. This is called reaction at A, which is similar to this type. Reaction at P, reaction at B, reaction at A. They are just the perpendicular component. But what they ask here is something which is not just reaction at A. It is reaction on AB. Reaction on AB. A, different one. Reaction on AB at A. Okay, so we need to find out the forces. We need to find out the forces that act at A, then work out the resultant force. And the resultant force is the reaction on AB. So that is what we need to do. Forces that act at A. So that is what we need to find out. I have forces. I have one of the forces that act at A. That is the RA. There is actually more than that. We also have EC. Let me see first. Okay, if you look at the question, right, you will realize first they say the vertical wall is smooth. Okay, so this is smooth. This is also smooth. Then they also say that the rod is smooth. So the rod is also smooth. So one thing that they don't say it is smooth is the horizontal. The horizontal plane over here. Really hinge to the horizontal plane at the point A. Okay, then hinge it here. Hinge. So when I say hinge, that means they are like something that lock it up. There are something, maybe a ring that lock up the ring, avoid it from sliding. It is hinged over here. Okay, so because of that, right? Imagine that there are action here. There are also forces that act horizontally for the RQ. We should have forces that act this way as well. Forces that act this way, which balance off with the forces over here and over here. Okay, let's take a look. We should have forces that act over here as it is in equilibrium, right? Okay, let me see first. Okay, so let's come back to this picture again. So this time I'm going to use horizontal. This is horizontal. This is horizontal, act to the right. And because this part is hinged, so I expect here to have forces, either act to the right or left, we are not sure, but we just simply put one direction first. Okay, so if our setting is not correct, later you will get negative answer, then you should know it should be the other way. So I assume it acts this way first. So this way, so this one I call it hinge. Okay, reaction because of the hinge. So I have three horizontal components that I need to work out. Okay, so horizontally, I have reaction because of the hinge plus reactions, the horizontal component RQ sine 60 degree equal to this one RB. Okay, now my main concern is find RH. Find RH. So RH, my RQ I already know, which is 2W. 2W square root 3 over 2. RB is this value. 7 sub 3 over 9W. And then I get RH. 7 sub 3 over 9W minus sub 3W. So I need to work out this one. This one 7 over 9 minus 9 over 9. Okay, negative 2 over 9. So like what I mentioned, we simply set the RH in this way. Actually, we are not sure whether it acts to the left or acts to the right. But the thing is, once you get negative, right, that means our setting is automatically means it's act to the left. It acts to the left. Okay, so now let's see the rod again. So since we get negative, that means it acts this way. 2 over 9 sub 3W. That is the RH. Then we also have the RA, which is 3W. Okay, so we want to work out the resultant force. The resultant force is the diagonal of this rectangle. So this is the resultant force. This is the reaction on AB. So reaction on AB, it acts on this rod AB at point A. So we want to find this, and we just need to use Pythagoras theorem. So reactions. Reaction on AB at A. Okay, so we make use of the resultant force 2/9 sub 3W squared 3W squared square root. Then we get 4/81 times 3W squared 9W squared square root. Okay, so we just use calculator. 4/27 plus 9. So we get 247/27 W squared square root. Then we get okay, we have to square root that fractions 3.02 W. So like that. Okay, so that's the answer. Any question or not for this?
So for this question, right?
Yes.
We count like if they join some object with the ladder, then we count both as separate.
Yes. Count
like this one is a disc and a ladder, then we take both as separate objects, then we calculate then we resolve the forces.
Yeah, true. That's the thing. Especially this one. This one very easy to make mistake. The reaction at Q. The action reaction at Q.
Okay.
Yeah. Separate them and form equation. If you put together and form equation, so that will be too many unknowns. So that's the thing. Kind of hard actually.